that there is an option called power line extractor.
Yeah, that's the main task that identifies the hits on the wires and creates vectors. So we do have a set of tasks that we use internally, like that I could send you, but you can also just, if we create a couple of quick tasks for you here, you'll have basically the same workflow. So there's two main parts to doing the wire extraction. The first part, well, actually, there's three main parts. The first part is we do need to have a center line. So the way that the point cloud task works is we feed it a vector, we feed it the center line, and then it goes along that line and uses the algorithm to detect hits on the wires and create the catenary vectors. Very strictly speaking, you don't even need a center line for the algorithm, except the center line just constrains it tells it where to go look, right? If you had a big data set and you just say go find wires, it would just choke on it, right? Because it's just trying to.
This center line, and normally it's between the flight lines, or
Normally
not
it is based on the towers,
the
and
towers.
it's the center of the corridor. So it's centered on the towers typically, because so that you have pretty much equal distance on either side to cover the wires. So in in a lot of cases, the utility company will have a center line, but it may not be very accurate. So part of what we do in the wire processing is we update or correct the center line. Basically, what you want to do is I would switch your view to a tin view instead of points.
Like this?
Yeah, and I would switch to elevation. I just find it easier to pick up the towers and elevation. You don't need to do it this way. You can use whatever display works for you. But what I want to be able to see is the towers. So if you zoom in, I assume there's just two towers, one at each end there.
I think there is one over here.
Oh, there's one. Okay.
Oh yeah,
And then there's the tower. So
Okay,
if you
and the
go to
other
the
one
if
should
you go to
be.
the end. Yeah, that's just wires. Oh, maybe there's only one tower. Or maybe right at the end.
I think it's here.
I think it's right at the end.
Yeah.
Yeah. So what I would do is I would create a layer. So create a new feature layer in your project. Yeah. So you create a feature layer. So we're going to create a new feature layer. So you have to give it a path. So just if you click the little browse button and select a folder where you want to put it. But you could call it whatever you want and then give it a name. Okay, and we're going to make this select geometry type. Let's make it a 3D polyline. And enable M values. We probably won't. That's just the standard that we use for wire processing. You probably don't need it here. So click OK. All right. So now on the feature edit toolbar, you can go to create a feature. So the same toolbar you were just on.
Okay.
Okay. And then just to the right of where you created the layer is create feature. So you click on that. And now you're just going to digitize a line down the center. And you can probably zoom out. You don't have to be too accurate. You can zoom out and you just left click to start. So you want to be a little bit past the end of the line there. So a little bit more to the left. Yeah. And then just double click to end. Okay. So now you've got a center line. You can change the color of that if you want to, or do whatever you want to do to make it more visible.
Yeah.
I usually just thicken it up to like 3 or 4 or something.
Yeah. Here, like, what should I use? I think that's okay.
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 Okay. If you go in, if you zoom in a little bit, we're going to need to know how wide the corridor is. Oh, yeah, that guy. So you sort of measure from side to side on the wires.
On the wires, right?
Yeah, so what that's about, I can't see, where's the readout? 6 meters, maybe?
Yeah.
So a corridor is probably about 12 meters wide, like with the wires, and we want to be a little bit bigger than that, right? So we'll probably make it 15
15, I think.
meters. Yeah, yeah.
Okay.
Okay. Okay, so now we have a center line. We want to set up your point cloud task. So you go to your point cloud task, and you're going to create a new task because you don't have the default ones. That's fine. So we're going to add a new task, and you're going to add that power line extractor task. Okay, and call it whatever you want to call it. Okay. Okay. All right. So there's a bunch of settings we need to figure out here. The other thing that we're going to need to know, so we know the width's about 15 meters. The other thing we want to know roughly is how high the wires are at their lowest point above the ground.
Okay.
So the best way to kind of estimate that is if you just take a profile along the corridor, so we can see the wires in the ground. You don't want to make it, yeah,
5's okay.
yeah, probably, yeah. I would think it might be too. The problem with the profile is yeah, okay, there we go. So I don't know. Kind of, you sort of see on the right, to the right of the center, there's some bushes that come near the wires, right? Yeah, a little bit further to the left.
Oh, this one.
Yeah, or even those guys. Yeah, right there. So zoom in on that area. And just roughly measure from that lowest wire to the top of the bush. What is that? It looks like
10 meters.
10
10
meters.
points. 10 point something, yeah.
Yeah. So again, we want to be a little bit conservative, which means make it a little bit smaller. So maybe we'll go with something like 8 meters.
8 meters.
Yeah.
Where should I put here?
Okay. So so let's start from the top and go down, and we'll come back to those numbers. So
Yeah.
your feature geometry is going to be tool geometry. Units can be meters. That's fine. You've just got the one LAS layer. Check the source filter. And let's do a scan. So click the scan button upper right. See where all our points are. I always like to check this. They're probably in class 0. Yeah, so class 0. So that's fine. So we want to, yeah, exactly. So click OK. Okay, we're going to classify the lines. We're going to use a single class. Going to go into class 14. Yeah, that's the typical one that you put the points in.
Okay.
We're going to save the line, so we're going to vectorize the line. So you need to give it a file location to put the catenaries. Yeah.
Let's put here. Power line. Overwrite.
Yeah, may as well. That's usually what I do because when you're doing demos, you're usually just rerunning the same data set, right? So you're not adding to the file.
Yeah.
Okay. So now we've got, if you scroll down, there's 6 parameters that we need to configure here. So first, corridor width. Okay, so we said about 15 meters, I think. So we just put 15 in there. Okay, minimum height, I think we said was 8 meters.
Yeah.
Okay, now void space and non-void space. We can talk a little bit about those later, but I would just try the defaults. This is, do you know, is this 515 data?
It's 515, yeah.
Yeah, so let's try 1 meter for the void space. And I think 0.5.
What does white space mean?
I'll have to show you a picture. Hang on here. Let me just, I'm
You can
not
explain
sure.
later if you want.
No, let me explain that. It's good time to explain it. void space and non-void space. Here we go. Come on. So the way the algorithm thinks about a wire, right? It
Mm-hmm.
takes a, a, a cross section cut through the wire
Okay.
into a slice,
Mm-hmm.
basically,
Mm-hmm.
and it assumes that a wire is in the center of that slice. So that's the big black dot you see in the center, right?
Mm-hmm.
And then it assumes that there's going to be some noise in the lidar data, right? There's going to be the points aren't all going to be on the wire. They're going to be a little bit fuzzy, like they always are, right?
Okay.
So there's a certain area around the wire where
Uh-huh.
we can have some points, and that's called the non-void space. Basically means we can have some points within this distance, right,
Okay.
of the wire, and we know that those are probably hits on the wire. They're just noisy, right? Obviously,
Okay.
the less noise in the system, like if you use a Regal system over a 515,
Mm-hmm.
the smaller you can make that non-void space. So in order to be a wire, you not only have to have points in the non-void area, a wire, a free hanging wire, then has just empty air around it, right?
Mm-hmm.
Hopefully, ideally, right? So
Yeah.
so that's that next bigger, larger circle, and that's what we call the void area.
The void
And so
area. Okay.
the algorithm, it looks for points that are grouped in the non-void area, surrounded by empty space in the void area.
Mm-hmm.
And if
Mm-hmm.
it finds those, it says these are potential wire hits.
Okay.
It then does some other stuff after that to try and hook all these slices up together and vectorize them. Because of course you could just get some random points out in the canopy or something like that
Great.
that would look like this, but they're not part of a
Mm-hmm.
continuous wire. So it
Okay.
does a little bit more smarts by this. But that's essentially what it means by void and non-void. Main thing is the void the non-void is driven by how noisy the data is,
Mm-hmm. Mm-hmm.
and the void is driven by how far apart your wires are. Yeah. So,
So one
uh,
meter here would be enough, basically.
yeah, what we would actually do is if we hadn't worked with the data set before, is we'd take a look at a cross section through the wires, because you could maybe make that a little bit bigger. But this is the default I suggest starting with, and then we'll tweak it if we need to for your data set. One of the things about the power line extractor, similar to the ground classification, you can't really say, these are the values to use all the time. That
Exactly.
they
Depends
they
on the
they
data.
it depends on the data, it depends on the wires, it depends on
Yeah.
the underlying terrain. So you do have to
This
have a
way.
little bit of willingness to tweak your parameters. But we'll start with
Yeah.
this. So the non-void, I would put as 0.5. So what this is basically saying is that, a wire bundle has a sort of blob of about 50 centimeters, which is actually pretty large
Mm-hmm.
for a 515, and it has nothing else within 1 meter of it. Right.
Okay.
Basically
Okay.
what that says. So the last two we barely ever change these. The last two, the wire thickness, I would put
Mm-hmm.
as 0.5. Generally, you want to put wire thickness the same as non-void space. And as a matter of fact, we're probably going to get rid of this parameter in the dialog. We're just going to set it, automatically to that, because you
Okay.
rarely change it. The vertex spacing basically says, so it's going to create a catenary, right? It's going to create a vector for the wire, and it's
Mm-hmm.
just how far along do you want vertexes? Some companies want, they want like a vertex every 5 meters or every 10 meters or something like that. So this is where you can set that. We default it to 5 meters. So one, a vertex every 5 meters, and nobody's ever really changed that or asked us about it. So these
Yeah.
last
Yeah.
two
Yeah.
values, you just leave those. What we can do actually is draw a profile perpendicular to the wires. So draw a profile just across the wires. Yeah.
I'll be.
Oh, just the width of the wires is fine. Doesn't have to be too big. Okay, and then you got to find the wires. They'll be up in the air somewhere. Okay, so zoom in on those guys.
Okay.
Okay. So if you measure um, how big the blobs are, so you measure side to side on the blob, right? What is that?
I got
Yeah.
it. Yeah.
So
I
these are
got
our wires. Now, unfortunately, this data set, you've got two wires. All right.
like
What is that? It's about
zero
four,
point
so 40
5.
centimeters.
far receiver, yeah.
Yeah, so that's that 0.5. That's 50 centimeters. We're saying so everything's within 50 centimeters is a wire, right?
Okay, yeah.
Now, if you measure between the so measure from one set of red points to the lower set of red points or something. You see, it's probably much more than a meter, which is fine.
Like from here to
Or
here,
no, to the nearest one. Yeah. So what's that? So that's 3 meters,
three,
right?
3.6, yeah.
Yeah, and if you go to the
3.6.
one above it, that's 4, right? So 1 meter is actually quite conservative. All of these, if you visualize, all of these have at least a meter of empty space around the 50 centimeter blob, right?
Yeah, yeah,
Yeah, you could probably even go to 2 meters and you would be fine. And
yeah.
the reason you would do that is if you had a lot of vegetation, it would even more reduce the number of false positives in vegetation. But we'll stick with 1 meter, and it's probably
Mhm.
okay. So if you go back to your point cloud task, so we've got the settings set up. We're not going to do any grouping. I think you just need to apply that to save
Yeah.
it. Okay.
Mhm.
So the way that we typically run these
Mhm.
is we run them against the specific layer. So yeah, yeah, exactly. Oh, sorry, you need to save your cancel out of there. You need to go save your line. Oh, you did. Okay. Right.
Yeah, it's applied. Yeah.
I would save the project anyway, right? Before we run this,
Okay.
just to be
Just in case.
always good to be. Yeah.
Yeah. Okay.
And you want to run against not flight lines. No. You want to run against your alignment, tower alignment. Yeah. And click run. Okay. So if you go to your table of contents, okay. So if you zoom in, we should see if it created any wires. Looks like it did, right?
Yeah, it did.
So you can look at those in cross section to see what they look like. And so you look at them. I usually look at in a cross section along the corridor.
Yeah.
Yeah, so you see it's done a pretty nice job of capturing those wires. It's
Good.
also classified the points into the wire. What you can sometimes do is if you bring up live view, yeah, okay, and redo the scan, and we'll see we should have wire points. Well, we will have wire points. So you see it found
Yeah.
77,000 wire hits. If you turn that class off, you'll just see the vectors, right? So if you turn off class 14, just class 14, not all of them.
Oh, okay. Sorry.
Yeah.
Turn it off, right?
Yeah. All right. So now you can see. So now you can see the wire vectors without any of the points, right? So it's nice to be
Okay.
able to see that. You see, it did it. It looks like it did a pretty decent job,
Oh,
right?
that's good. That's good because I just see. Okay, good.
Yeah. Now it does look like. So you can close out of there. Yeah. So now that you have the wire vectors, the last step we do, which is the important one, right, is to find the
Yeah.
encroachments,
Mm-hmm.
right? And so for that, we need to set up another point cloud task. We'll do a new task. And this one is actually an old one. It's called classify by feature. Yeah. But what I would call it, because it's very specific, we usually just call it classify encroachment or classify zone A. We do actually do like zone A, B, C, D, but I don't think you need to do that for.
Only.
I would call it say classify danger zone. That's actually might be a good way to
Yeah.
click OK. Okay, so again, it's tool geometry. We go with meters, active LAS layer. So source points. So you want to turn off everything except for class 0. So we don't want to search the wire points. We know those are close to the wire and the towers. Now, you kind of have a bit of an option here. So what we would do in production is we would have classified out the towers already. So we would put the tower returns off the towers into the tower class. You can still do this. What it means though is your towers are going to show up as being close to your wires, because of course they are. So if you wanted to do it a little bit more closer to production, what I would do is I would start with your towers manually classified into the tower class and just say you pre-classified the towers or something like that. Okay, and then what you want to do is you want to draw a profile across each tower. Yes, that profile's, yeah, so just draw a profile across that tower right there. And a little bit wider so it covers the whole tower. Yeah, you probably have to, there we go. Perfect. Okay, perfect. So now you're going to use the above line, or actually use the, oh, you could use above line, I guess it's fine. You could use the above line tool, guy. And at the bottom of the tower, yeah, exactly. And then hit
space.
space, yeah. Okay. And if you look at that by classification, they should be, I think that by default, they're blue. So if you change your display to by classification, yeah. Oh, I guess you have a different color. That's okay. So now we just need to do the same thing at the other tower at the other end. It's right there. Yeah. Yeah. Just got to find it in there. There it is. Yeah. There you go. Okay. So now with the towers classified out, so now when you go to that point cloud task, which was classify our danger zone, right? Okay. So the tool geometry, we're just going to input it. Units will be meters.
Yeah.
Active las layer is fine. So source points, we can double check that, but it should just be unclassified. Yep.
Yeah.
Or never classified. Sorry, that's okay. And scroll down a little bit. We need to see that next window. So this is a general tool that just classifies based on some spatial relationship to the feature. So we want to do within a distance of, which we have, right? And then if you click in that where it says 1 box, within a distance of, and then 1, and you sometimes have to click, yeah. So this basically tells us how far from the wires do we want to look for danger points. There's no set fixed number here. It just depends on the customer and what they want, right?
Okay.
The thing is, for the data set, you may not have anything that's really that close. So I'd make this a little bit larger, maybe make it, I don't know,
8.
10, yeah, 8. Yeah, try 8. Yeah, 8. 10's probably too much. Eight's fine. And then the destination class, you want to click on the destination class. It's going to reclassify the points, and we would typically use here class 20. And you could rename the class. We call it like, zone D or something like that. But
Where do that? Is that?
Yeah, as long
Just
as you hit,
like this?
yeah, just 20 is fine. Click OK. Click apply. Okay, so this one you're going to run again against the feature layer. So same as you did with the center line, but now it's going to be the sure wires. Where are your wires? PL extractor. Yeah, that's it. And click run. Okay, so look, check to see You can probably do that if you go to live view, the yellow filter, live view. Kind of wish they'd give us a little report and scan. We'll see how many returns we got. Yeah, so you can see you've got 25,000 points in that class. I would change that color on ignored ground. Yeah, I would make it bright red. That's what I typically do, so they stand out. Yeah, so you want to find out where your points are. Turn off your unclassified points. Yeah.
Everything on.
Yeah, and then go to 100% display.
Okay, so
Yeah, so
then
now,
classifying is off.
yeah,
Should I close that?
you can just minimize it. You don't need to close it. Yeah, that's fine. And then turn on 100% display. And I would actually change out of the tin view. I would turn back to the point view because we're looking for clusters of points, so it's usually a little bit easier. There you go. So there you can see stuff within 8 meters are your blue points. I thought we changed that to red, but that's okay.
Okay.
All
Yeah,
right,
it
so
should be
now,
in red. Yeah.
well, because you probably didn't save the ignored ground yet. Yeah, there you go. So now if you draw profiles across those, you should be able to see, what that looks like. I would typically draw it perpendicular to the wires. That's usually the best view to kind of see how, yeah, exactly. So here, what you need to do is you need to turn your, so go back to your live view filter. Okay, and in the top, switch off the map, those check boxes that says map and 3D and preview. Actually, you could leave the 3D on because you do use that, right? And then turn the unclassified back on. So this will turn on the unclassified points in our profile view, but we don't want them on in our map view because then we can't use 100%. Yeah. There you go. Okay, and if you switch that, the profile view to by class, then you'll be able to see where your encroachment is. There you go.
Okay.
So now you can see, so there's your red, there's your encroachment zone, and you can scroll your profile back and forth a little bit and see what it looks like. And this was 8 meters we used, right? So
Yeah.
you sort of can show, okay, so there's some vegetation that's within 8 meters of that bottom wire. You notice how the wires on the left seem to be hanging a bit lower than the wires on the right?
Yeah.
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 And you can do that with each of these zones. You will notice, I think it looks like some of our wires got classified as danger zones. Again, that can happen if we didn't clean up the points. But this
And
looks
can I
pretty nice.
go? There is a fastest way to go to that point. I mean, like jump button or something like that. Or I just need to drag the profile every time that I want to see that point.
Typically, you just draw a profile if you've got
Here's a
just a short
profile.
little section like this. There is a method you can go through where you can basically create what we call cluster points.
Mhm.
But I don't think for a short section like this, it's kind of worth doing. Or you could rerun it and make it 9 meters if you wanted it a little bit bigger or something like that.
Yeah. Okay. Good.
All right.